Today's lesson is called Quadratic Equations, Differences of Squares. I want to point out the word differences is another word for subtraction. So that's something you're going to notice is very important in this. You're going to see a subtraction of perfect squares. That's what differences of squares mean. 81 is a perfect square and c squared is a perfect square. So what you do is when you factor these out, 81 factors to a 9 and a 9. A C is to a C and a C. The difference, though, one will be a positive, one will be a negative. Okay, so let's do that again. 64G squared and H squared will factor. They're both perfect squares. 64 makes 8G and 8G, and then an H in each one. One's positive, one's negative. Doesn't matter which order, as far as which one you make positive, which one you make negative. Let's do it again. This time we're going to have an X in each one, and the perfect square of 9, square root would be 3. One's positive, one's negative. That's how you start out. They're going to get different, of course. They're not all that easy. So here we go. This time, when we factor these out, the perfect square of 1 is a 1 in each one. One's positive, one's negative. And then y4 would factor to y2 and y2. But we're not finished. The reason is this one right here is still the difference of squares, because y squared and 1 are both perfect squares. So this one can be factored further. So the y squared plus 1 comes on down. Then this one will break up into 2 more. So some of your answers can have 3 binomials. And this breaks to y minus 1 and y plus 1. So that's what you have to watch for. Make sure you factored it as far as you can go. Okay, we'll do this again. We'll start out. 4 would be, and 4a4 becomes 2a squared. 2a squared. b4 becomes b squared. And b squared. One's positive, one's negative. Now look at your negative one. Can that be broke? Are those both perfect squares? Is 2 a perfect square? And no, it is not. So we cannot factor these any further. We are done at this step. You should always have to check if you can. Okay, let's go to some more. Start out here. 81 is a perfect square, breaks to 9 and 9. X4 breaks to X2 and X2. One's positive, one's negative. Now look and see, do you have anything left to factor? Is this a difference of squares? And it is, because 9 is a perfect square, so is x squared. So let's go one step further. It's 9 plus x squared here. Then this one breaks into 2 more. 3 minus x and 3 plus x. Oops, my x there. And you are welcome to check these to see if you can go back to the original problem. So there it is. Everything's factored as far as it will go. Now on this one, you should notice the 2y4 is not a perfect square, and neither is 50. But can we factor out anything? And yes, we can bring a 2 out. So if we bring the 2 out, we'll be left with y4 minus 25. Well, now we have difference of squares. So let's continue with the 2 out here to the side. This breaks down to y squared minus 5 and y squared plus 5. Now look at our difference. Is this a difference of squares? No, it is not. So we stop right there, because 5 is not a perfect square. And there's our answer. It's factored as far as it can go. Okay, let's keep going. Now on these kinds of problems, they look a little bigger, a little longer. Well, if you'll remember back when we first started factoring I would tell you to break it into groups and factor by grouping. So we're going to do that here. The first one, we're going to pull out an m squared. So if we bring out m squared, we'll be left with m plus 1. Then on the second one, let's pull out a negative 25. And we'll be left with 25m, no, I'm sorry, 2m, getting ahead of myself, minus 1. And I left my 2 off here. And it's a plus 1. I'm messing this one all up. Let me start that over. Okay, first one, we're going to factor out an m squared. We'll be left with 2m plus 1. The second one, we're going to factor out a negative 25. So we'll be left with 2m plus 1. Because negative 25 from negative 25 makes a positive 1. So there you have the same factor inside each of those parentheses. So final, we have 2m plus 1, and then the m squared minus 25. However, you should notice this is a difference of squares, the last one, so we can break it up even further. So the 2m plus 1 stays. Then this one breaks into m plus 5 and m minus 5. There's our final answer. Let's do this again. We're going to break this up into groups to factor. First one, we're going to pull out r squared. It's the most I can get out. It'll leave me 1r plus 6. The second one, I'm going to factor out an 11. It will leave me 1r plus 6, which is exactly what I want to see. So we're left with r plus 6 times r squared plus 11. And we're finished because this is not a difference of squares. There are no differences, so this is over. There's our final answer. Okay, a little bit more. So now we're going to solve each equation by factoring. Remember, this is where you want your equations to set equal to 0. So first thing we'll do is bring our 81 over by subtracting it. And now it's set equal to 0. And on the other side, we have difference of squares. So we can go ahead and factor it quite easily. It'll be 2y minus 9 and 2y plus 9. Now we'll go ahead and set each one equal to 0 to solve them. 2y minus 9 equals 0. Add 9. We'll have 2y equals 9. Divide by 2. So our first answer is y equals 9 over 2. But I'm going to give you a shortcut. The second one is going to be a negative 9 over 2. But it'll be exactly the same. So the way you're going to list your answers on these problems is going to be a positive or a negative 9 over 2. All you have to do is solve one, and you know you're going to have positive and a negative of either answer. Let's do that again. Okay, where we can factor, they're not perfect squares, but can I take anything out? Let's start with the 2. Let's take out a 2 and see what we've got. 98 divided by 2 is 49b squared. 50 makes 25 equals 0. So let's keep going. This is difference of squares. So we're going to break that apart. And we will have 7b minus 5 and 7b plus 5. Now we're going to take one of these, set it equal to 0, and find our answer. Now, the 2 outside, if you say 2 equals 0, is that possible? No, 2 does not equal 0, so 2 is not a solution. we're trying to find solutions to this, and 2 is not one of our solutions, so we will not use the 2. But the 7b minus 5, go ahead and solve for this one. Add 5, so you have 7b equals 5. Divide by 7, so our answers would be a positive or a negative 5/7. And again, the 2 is not included because 2 does not equal 0. 2 more. Get my screen to go up. Get that off. Okay. 2 more. Here we go. Okay, here we go again. We're going to have this difference of squares. So we're going to break these up into 2 binomials again. T will be in each one. Now, when you have perfect squares on the numerator and denominator of a fraction, just take the square root of each one. So the square root of 64 is 8, the square root of 121 is 11. So you're going to have 8 11ths on each one. One's plus, one's negative. Then you're going to set them equal to 0, one of them. T plus 8 11ths equals 0. You subtract your 8 11ths, so T equals negative 8 11ths. Or T will equal a positive 8 11ths. So it's positive or negative 8 11ths. That's just a shortcut way of writing it, so you don't have to solve each one. Okay, one more. Break it into 2 binomials. 1 over 36 perfect square is 1/6 x, 1/6 x. And then 25 is minus 5 and plus 5. Now, we're going to pick one of these to set equal to 0. 1/6x minus 5 equals 0. Start by adding 5, so you'll have 1/6x equals 5. Now, to get rid of a fraction that's being multiplied, flip it and multiply its reciprocal. So really, you're doing 5 times 6. So x can be positive or negative 30. This one will give us a positive 30, but the other one will give us a negative 30. That's why it's positive or negative 30. 2 answers. And that's your lesson. I will see you in class.